Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
This episode was generated using artificial intelligence. Please verify facts.
Hi Herman and Corin. So we're going to do something a little different in today's episode, or this episode among those produced today. We've talked about our production pipeline in a number of episodes, and one of the things that I haven't used yet is uploading images. I think we've successfully validated uploading a document, so this is going to kind of be a live proof of concept. If it goes wrong, I will delete the episode. Occasionally we do that afterwards, but hopefully it'll be smooth sailing and you'll be able to see the photographs that I send you in addition to this prompt. So today is it won't be the most scintillating maybe for the majority listeners, but for anyone who is into DIY and monitor mounts and wants to learn about rivnuts, this might be good listening. So you can see Herman and Corin from the photographs exactly what's the little DIY issue I'm trying to tackle. I have these monitors, which I'm hoping to replace pretty soon. These are the workhorses that have been around for 10 years, and I recently upgraded to a new mounting system. So I was taking them off, reconnecting them, and I noticed that a number of the what you screw into with the VESA pattern, the threaded inserts weren't there. So I got this, I opened up put that into ChatGPT, asked for instructions, opened up the monitor firstly, which took a bit of pricing. Good pricing tool is key. And then I saw that I was able to eventually extract the pieces out. Now they have an M4 machine screw female on the top, and then on the bottom they're basically flat. And looking at the backboard, these were machine pressed into the metal at the back plate of the PSU, which is what you're looking at. And doing this, so this seemed like it should have been a fairly easy repair job. I was able to get the inserts that fell through out, but a bit more challenging in reality. So ChatGPT recommended what's called a rivet nut or a rivnut, but my local DIY place had never said they didn't have it, and that rivnuts weren't really popular here. I couldn't just press it directly back into the metal plate because there would be nothing to actually hold it. I guess it's like machine pressed at manufacture, and I can't open up that metal box, the PSU, because there's really no access mechanism. And we mentioned in the electrocution episode, this might be one of those things you don't think about as not such a good idea to avoid doing, but probably in that category. So I'm limited to trying to find a way to reattach, and it doesn't have to be this specific rivet nut or whatever this part's called. It can really be anything that'll catch a M4 machine screw at the right position and allow me to make those proper 4 points of contact with the VESA plate on the mounting bracket. Herman and Corin, what would you recommend for repair for this particular problem? And for those who work with VESA mounts for monitors and stuff like that, I want to have a couple of components ready for situations like this. Could you solder it in? Or what about one of these actual rivet nut press machines that you can see, the rivet guns, electrical, mechanical, or just simply buying an M4 nut? But I don't think that would work because it wouldn't attach flat. Anyway, Herman and Corin, repair diagnostics, please. And take a look at the photos and let me know if they came through.
Hey everyone, welcome back to My Weird Prompts. We are coming to you live from a very sunny, very ancient feeling Jerusalem today. I am sitting here looking out at the stone walls, and it is the perfect backdrop for talking about things that are built to last. Or in today's case, things that were built to last but then decided to fall apart in the most inconvenient way possible. We are tackling a very specific, very relatable DIY headache today. If you have ever tried to set up a custom home office, a high-end gaming rig, or one of those ultra-compact small form factor builds, and realize that your hardware just is not cooperating with your vision, you're going to feel this one in your soul.
Herman Poppleberry at your service. And yes, Corn, this is a classic case of what I like to call the missing link, or in this specific mechanical context, the missing threads. We received a fascinating prompt from a listener named Daniel. He is dealing with a monitor mount issue that is essentially a structural nightmare disguised as a minor inconvenience. He is trying to mount a monitor, but the threaded inserts on the back of his power supply unit case, which are supposed to follow the standard VESA pattern, have basically disappeared. They have either fallen inside the unit or were never properly seated to begin with.
Right. And the real kicker here, the thing that makes this a true My Weird Prompts challenge, is that Daniel cannot open the box. It is a sealed power supply unit, or PSU. Now, we have talked on this show before about why you should generally stay out of the inside of a power supply. Those capacitors can hold a lethal charge for a long time, even when the unit is unplugged. But that safety constraint creates a massive mechanical challenge. You've got a hole in a piece of thin sheet metal where a screw is supposed to go, but there is absolutely nothing for the screw to bite into. It is like trying to hang a heavy picture frame on a wall made of wet tissue paper.
It is the ultimate blind hole problem. In a perfect world, if you are mounting something to metal, you can get a nut on the back and tighten it down, or the metal is thick enough to be tapped with its own threads. But with these thin electronics cases, which are usually only 0.8 to 1.2 millimeters thick, you cannot just tap a thread into them. There is not enough material for the screw to grab. So, manufacturers use these specialized inserts that are supposed to stay put forever, until they do not, and when they fail, they leave you with a smooth, empty hole and a very heavy monitor that has nowhere to go.
So, looking at the situation, Daniel is asking about a few specific options. He mentions soldering, using a rivnut press, or maybe a standard rivet gun. He is looking for 4 solid points of contact for an M4 machine screw to hold that VESA plate securely. Herman, I know you have been obsessing over the photos he sent for the last hour. What is the first thing that jumps out at you when you look at those empty holes?
Well, the first thing is identifying what those original parts were, because that tells us why they failed. In the manufacturing world, those are almost certainly what we call self-clinching nuts. Most people know them by the brand name PEM nuts. They are fascinating little components from an engineering standpoint. They have a knurled platform and a specially shaped groove. During assembly, they are literally pressed into a pre-drilled hole with tons of force, sometimes several tons. The metal of the case actually cold flows into that groove, locking the nut in place so it can handle both torque, which is the twisting force of the screw, and push-out forces.
But clearly, the cold flow did not go with the flow here. If they have fallen out, it means something went wrong in the factory. Either the hole was punched slightly too large, or the pressure applied during the pressing process was off. Oh, and this is what I suspect happens with a lot of monitor arms. Someone might have over-tightened the screw or put way too much leverage on the mount. If you have a long monitor arm, it acts like a giant crowbar. One good yank and those PEM nuts just pop right out of their seats and go rattling around inside the case.
Exactly. And since they are now floating around inside the power supply unit, or gone entirely, we are dealing with a void. Daniel mentioned soldering as an option, and I want to address that first because it is a very common thought for people who are used to working with electronics. Corn, as our resident voice of reason, what do you think about the idea of soldering a threaded insert onto a thin steel or aluminum case?
I mean, my gut instinct says it is a recipe for absolute frustration and probably a ruined power supply. Soldering is for electrical connections, not structural ones. If you are using a standard soldering iron, you are never going to get enough heat into the case material to get a real bond. The case acts like a giant heat sink, sucking the heat away before the solder can flow. And even if you broke out a blowtorch, which you definitely should not do near a power supply, solder is soft. It is mostly tin and lead or copper. It has almost zero shear strength. The moment you hang a 20-pound monitor on that mount, the solder is just going to peel right off like a bad sticker.
You are spot on. Soldering is definitely a no-go here. To get a real structural bond with heat, you would need to move up to brazing or welding. But you cannot weld on a power supply unit without melting every capacitor, wire, and plastic component inside. The heat transfer would be lethal for the electronics. So we have to look at mechanical fasteners that work from one side only. This brings us to Daniel's other suggestion, which is the rivnut.
Now, I have seen you use these in the garage when we were working on that old bike frame. A rivnut, or rivet nut, is basically a hollow rivet that is threaded on the inside, right? It is like a hybrid between a pop rivet and a standard nut.
Precisely. It is one of the coolest inventions for anyone working with sheet metal or thin-walled tubing where you cannot reach the back. Think of it like a heavy-duty wall anchor, but for metal. You have a cylindrical body with a flange on one end. You slip it into the hole, and then you use a special tool, a rivnut press or a rivet nut setter, to pull the bottom of the nut toward the flange.
And that causes the middle part of the sleeve to collapse outward, right? Like an accordion or a mushroom.
Exactly. It bulges out and sandwiches the sheet metal between the flange on the outside and the collapsed bulb on the inside. Once it is set, it is rock solid. It gives you a deep threaded hole that can handle a lot of force. For an M4 machine screw, which is the standard for VESA 75 and VESA 100 mounts, an M4 rivnut is the textbook solution. It is actually a better solution than the original PEM nuts in many ways because it grips the metal from both sides.
Okay, so that sounds like the winner. But I want to push on the practicalities here because this is where things get dangerous. Daniel's case is a power supply unit. If he uses a rivnut press, he is going to have to make sure the hole is exactly the right size. If the original PEM nut fell out, is the hole already the right size for an M4 rivnut?
That is the big question. Usually, a PEM nut hole is very specific to the manufacturer. For a standard M4 rivnut, you typically need a hole that is about 6 millimeters in diameter, though it varies by the specific brand and style of the rivnut. If the hole is currently, say, 5 millimeters, he will have to drill it out. And corn, this is where we have to talk about the danger zone. Drilling into a sealed power supply unit is a high-stakes game. It is basically DIY heart surgery.
Right, because of the metal shavings. This is the part that scares me. If you are drilling through a metal case, you are creating tiny conductive spirals of steel or aluminum. We call it swarf. If even one of those tiny pieces falls onto the circuit board inside that power supply, the next time Daniel plugs it in, it is game over. It could short out a rail, spark, or even start a literal fire. And since he cannot open the case to vacuum it out, those shavings are in there forever.
It is a massive risk. If I were Daniel, and I absolutely could not open the case to clean it out, I would be extremely cautious. One trick is to coat the drill bit in heavy axle grease. The grease is sticky enough to catch most of the shavings as they are created, keeping them stuck to the bit rather than letting them fall inside. You can also hold a very strong vacuum nozzle right next to the bit while you are drilling. But even then, you have to be so careful not to let the bit plunge too deep once it breaks through. You do not want to spear a transformer or a wire bundle.
That sounds incredibly nerve-wracking. Is there a way to avoid drilling entirely? What if the hole is already close enough?
If the hole is just a tiny bit too small, he might be able to use a reamer or a small round needle file to enlarge it slowly by hand. It takes longer, but it gives you way more control over where the shavings go. You can file in an upward motion so the dust falls out of the hole instead of into it. But let us say he gets the hole size correctly. Then he needs the tool. Daniel mentioned a rivet gun. It is important to clarify for everyone listening that a standard pop rivet gun is not the same thing as a rivnut tool.
Yeah, I made that mistake once. A regular rivet gun pulls a mandrel until it snaps off, leaving a solid plug in the middle. A rivet nut tool has a threaded mandrel that you screw the rivet nut onto. It pulls the nut to crush it, and then you unscrew the tool, leaving the threads intact. You cannot really use one for the other unless you want to break your tool and ruin your project.
Right. You can find relatively inexpensive manual rivnut setters that look like long-handled pliers. For 4 holes, a manual one is perfect. You do not need the big pneumatic ones that professional auto shops use. But there is one more detail Daniel needs to watch out for: the grip range. This is the most common mistake people make with rivnuts.
Explain that. I assume that is the thickness of the metal the rivnut is designed to handle.
Exactly. Every rivnut has a specified grip range, like 0.5 to 2 millimeters. If the metal of the PSU case is very thin and he buys a rivnut designed for a thicker plate, it will not collapse tightly enough. The hole insert will just spin in the hole when he tries to tighten the monitor screw, and then he is in a real mess because he cannot easily get it out. He needs to measure the thickness of that case wall, probably with some digital calipers, and make sure the rivnut matches that thickness.
So, let us play out the alternative. What if he does not want to buy a specialized tool for a one-time repair? Are there any other options that could catch an M4 screw from the outside?
There are things called well nuts. You might have seen these used on kayaks or for mounting windshields on motorcycles. It is a rubber sleeve with a brass nut embedded at the very bottom. When you tighten the screw, it pulls the brass nut up and expands the rubber sleeve against the inside of the hole.
Those are great for dampening vibration, but can they really hold the weight of a monitor? Some of those new ultra-wide monitors weigh 20 or 30 pounds. That is a lot of trust to put in a little piece of rubber.
That is the trade-off. A well nut is much easier to install and does not require a special tool, but it is not as structurally rigid as a rivnut. If the monitor is small, maybe a 24-inch one, it might be fine. But for a heavy-duty arm that is going to be moved around a lot, the rubber might eventually perish or pull right through the hole. I would stick with the rivnut if at all possible for something as expensive as a monitor.
What about something like a toggle bolt? You know, the butterfly anchors people use for hanging heavy shelves on drywall. Do they make those small enough for an M4 hole in metal?
They do make small ones, but they are usually too bulky for this. You would need a much larger hole to get the butterfly wings through than the M4 screw requires. Plus, once they are in, they are loose until you tighten them. It would be a nightmare to try to align all 4 holes with a VESA plate while the anchors are flopping around inside the PSU case. You would probably end up losing the wings inside the power supply, and then you are back to the metal pieces floating near high voltage. Problem.
Yeah, that sounds like a recipe for a very bad day. So, it really feels like the rivnut is the professional, correct way to do this. But let us go back to the safety side of things. We are talking about a power supply unit. Even if he avoids the metal shavings, is there a risk of the rivnut itself touching something inside once it is installed?
That is a very real concern that people often overlook. A rivnut usually protrudes about 5 to 8 millimeters into the case after it is collapsed. Daniel needs to look through the existing holes with a very bright flashlight and see how much clearance there is between the case wall and the internal components. If there is a circuit board or a wire bundle right up against that wall, the rivnut could press against it and cause a short or physical damage.
And since he cannot open it, he is basically flying blind. This is why these things are machine pressed at the factory. PEM nuts are designed to take up as little space as possible. They are almost flush on the inside.
Exactly. The rivnut is going to have a much larger footprint inside the case. If space is tight, he might have to look at a different solution entirely. One wildcard option is a structural adhesive, something like JB Weld.
Now we are talking. Everyone loves a bit of epoxy. How would that work here?
It would be a bit of a hack, but he could potentially take a standard M4 nut, scuff up the surface of the case around the hole with some sandpaper, and bond the nut to the outside of the case.
Wait, wouldn't that make the VESA plate sit crooked? If the nut is sitting on top of the case, the plate will be pushed out by several millimeters at that corner.
It would. He would have to do it for all 4 corners to keep it level, and even then, he would need longer screws. And honestly, it would look pretty messy, but it would avoid the drilling and the internal clearance issues. However, the strength would rely entirely on the bond between the epoxy and the paint on the PSU case. If he does not sand it down to bare metal, it will just pop off the first time he moves the monitor.
It feels like we are choosing between a high-risk, high-reward mechanical fix and a low-risk, low-strength adhesive fix. If I were in Daniel's shoes, I think I would be leaning toward the rivnut, but with some very specific precautions.
I agree. The rivnut is the only thing that will give him the 4 points of contact stability he is looking for. But here is the Poppleberry pro tip for this specific situation. Use a manual nut and bolt method to set the rivnut if you do not want to buy the expensive tool.
Oh, I have heard of this. You use a long bolt, a nut, and a couple of washers to create your own press.
Exactly. You thread a nut onto a high-strength M4 bolt, then put a heavy steel washer on. You screw that whole assembly into the rivnut, which is sitting in the hole. You hold the bolt head perfectly still with one wrench, and you tighten the nut down against the washer with another wrench. That action pulls the threads of the rib nut up, collapsing the sleeve just like the tool does.
That is brilliant. It is slow, and you have to be very careful not to strip the threads, but it is a great way to do a one-off repair without buying a specialized kit that you might never use again. You just need a high-grade bolt, because a cheap zinc one from the hardware store will probably snap under that much tension.
Definitely use a grade 12.9 steel bolt for that. But even with that method, we still have the shaving issue if the hole needs enlarging. Daniel, if you are listening, if you decide to drill, please be careful. Maybe even try to tilt the PSU so the hole you are working on is at the lowest point. That way, gravity helps pull the shavings out rather than letting them fall in.
That is a good point. And maybe use a magnet? If the case is steel, the shavings will be magnetic. You could keep a strong neodymium magnet right next to the drill site to catch the dust as it is created.
That helps. But remember that many high-end PSU cases are aluminum, which is non-magnetic, so check that with a small magnet first. Now, let us talk about the VESA plate itself. Daniel mentioned he wants a solid connection. If he uses rivnuts, the flange of the rivnut is going to sit on top of the case. This means the VESA plate will be slightly elevated, maybe by a millimeter or two.
Is that an issue for a standard mount? Most of them have a little bit of wiggle room, don't they?
Usually no, because the screws are long enough and the plate is just a flat piece of steel, but it is something to keep in mind. He might need to put some small washers on the other holes to keep everything perfectly flat if only one or two of the original inserts are missing. If he is replacing all four, then the whole plate just sits a millimeter higher, which is fine.
That makes sense. So, to summarize the recommendation for Daniel, the rivnut is the way to go. It is the most professional fix that fits the blind axis constraint. Solder is out. Well, nuts are maybe for light duty, but the rivnut is the structural winner.
And specifically an M4 rivnut in a steel or stainless steel variety. Aluminum rivnuts exist, but for a monitor mount, I would want the extra thread strength of steel. Just make sure the grip range matches the case thickness, and you have checked the internal clearance so you do not poke a hole in a capacitor.
It is such a specific DIY problem, but it really highlights how much we rely on these invisible manufacturing choices. You never think about the threads in your monitor until they are gone. It is like the foundation of a house. You only notice it when it starts to sink.
It is the hidden architecture of our gadgets. Those PEM nuts are brilliant because they are cheap and fast to install in a factory, but they are not really designed for a repair scenario. Once they fail hard. They are a one-way street.
Well, I hope that gives Daniel a clear path forward. It is a bit of a project, but there is nothing more satisfying than rescuing a piece of hardware that looked like it was headed for the scrap heap just because of a few missing threads.
Absolutely. And it is a great skill to have. Once you own a rivnut setter or know the bolt and nut trick, you start seeing uses for it everywhere. You can add mounting points to your car, your bike, your kitchen cabinets. It is a game changer for DIYers.
We should probably mention, for the sake of completeness, that if Daniel finds that the hole is way too big for a standard M4 rivnut, they do make oversized or large flange versions. But if it gets much bigger than that, he might be looking at a more complex plate-over-plate repair.
Let us hope it does not come to that. Based on the photos, it looks like the holes are still relatively clean. The PEM nuts likely just popped out cleanly because of a bad press fit.
Alright, I think we have covered the mechanical side, but before we wrap up, I want to touch on the why again. Daniel mentioned this is a PSU case. In some monitor setups, especially those all-in-one style rigs or custom builds, the PSU is actually integrated into the mounting system. This is a lot of stress to put on a component that was primarily designed to house electronics, not act as a structural member.
That is a really important point, Korn. Most PSU cases are made of 0.8 millimeter or 1 millimeter steel. That is quite thin for a cantilevered load like a monitor arm. If Daniel finds that the metal is flexing too much even after the repair, he might want to consider a stiffener plate. Just a larger piece of aluminum or steel that he sandwiches between the VESA mount and the PSU case to spread that load out over a larger surface area.
Oh, like a big giant washer for the whole mount.
Exactly. It prevents the oil canning effect, where the thin metal of the case bows in and out. If you have ever seen a monitor that wobbles every time you type on your keyboard, it is often because the mounting surface itself is flexing, not the arm. Adding a 3 mm thick aluminum plate as a spacer can make the whole thing feel 10 times more solid.
That is a great tip. It is all about distributing that force. Well, Daniel, good luck with the repair. Let us know how it turns out, and if you manage to avoid any magic smoke incidents with the power supply.
Yes, please. Safety first. If you smell ozone or see a spark, stop immediately and unplug everything.
On that note, we are going to wrap this one up. It was a bit more nuts and bolts today, literally, but these are the kinds of problems that make or break a project.
If you enjoyed this deep dive into the world of blind fasteners and PSU safety, we would really appreciate it if you could leave us a review on your favorite podcast app. Whether it is Spotify, Apple Podcasts, or wherever you are listening right now, those ratings really help the show reach more people who might be staring at a broken monitor mount and wondering what a rivnut is.
Yeah, it genuinely makes a big difference for us. You can find all our past episodes, including our recent ones on electronic safety and home office setups, at myweirdprompts.com. We have got an RSS feed there for subscribers and a contact form if you have a weird prompt of your own.
You can also reach us directly at show@myweirdprompts.com. We love hearing about your DIY triumphs and your spectacular disasters.
Thanks for hanging out with us in Jerusalem today. This has been My Weird Prompts. I am Corn.
And I am Herman Poppleberry.
We will catch you in the next one. Goodbye.
Well, goodbye.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts, as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.